You know what I hate? Planning for peak use. Let's take the dining room table, for example. Maybe there's just two of you living at home, so for 99% of the time, a cute little two-chair setup would be great. But sometimes friends come over for dinner, so you need 4 or 6 seats. And then there's the holidays, when family comes over and that bumps up to 10 or 12 seats. And then there's that huge party you have at least once a year when there's like 20 people trying to eat at the same time. And then you need this gigantic table to fit everybody. And then, of course, you're back to just the two of you sitting at that giant table saying, "Hello down there, can you pass the..." Yeah, never mind. This is an even bigger problem when you're talking about servers for your design automation flow. Buy too many, and you've got a bunch of super expensive hardware just sitting around most of the year. Don't buy enough, and your whole project comes to a screeching halt when everybody fights for processing cycles. And buy just the right amount, and, well, you end up with both problems. Hi, I'm Amelia Dalton, host of Chalk Talk. There is a better way, my friends. Yep, the cloud. Cloud-based design automation is here, and it lets you have exactly the processing power you need, right when you need it. Today, my guest is Craig Johnson from Cadence Design Systems, and we're going to talk about EDA in the cloud. And before we get started, don't forget to click that link. There you can find even more information about the Cadence Cloud portfolio. Hi, Craig. Thank you so much for joining me.
My pleasure, Amelia. It's good to be here, and thank you for having me.
So the title of our Chalk Talk today is Cloud Computing for Electronic Design. Are we there yet? So, Craig, in order to talk about cloud computing, we really need to start with high-performance computing, right? So how exactly did we get here?
The reality is that to do electronic design, it's incredibly compute intensive. And the way that we can look back and see how the highest performance computing platforms evolved is a simple graph like this one. It goes all the way back to the 40s and 50s when the first large-scale computers were actually mainframes. And what we saw evolving over time is that eventually mini computers emerged, high-powered workstations emerged, and those largely were reducing the expense of the compute. Sort of in the 90s and moving into the 2000s, the client-server model really emerged as the preferred compute approach, where a local control through a client was actually accessing higher performance compute in a server farm. And that eventually led to what today we would loosely call cloud computing. So the history for high-performance computing has really spanned this multiple decades, but it's got us to where we are today in something that people loosely call the cloud.
So, Craig, what kind of cloud service I need depends on my design needs, right? How do these services and platforms break down?
Yeah, what I have found interesting is in talking to a lot of different customers, the terminology actually becomes a barrier to understanding. So a simple diagram like this one that points out what the different cloud service models are can be really helpful in understanding the macro cloud environment. And the way to think about it is really like a pyramid, where as you move further up the pyramid, you're taking advantage of services that are implemented at a lower level. It all begins at the base level, something called infrastructure as a service. And this is the foundation of cloud. And it's a model where the user brings their own software and rents the hardware from the cloud provider. And examples of these are the large major cloud providers that we're quite familiar with, from AWS, Azure, Google, Alibaba, IBM, Oracle. All of these companies offer this model. Moving one level up, the use case changes a little bit. There are often companies who want to create services or want to provide a software solution. And rather than start at the most basic level of buying a C compiler and beginning to write basic code like that, they can actually begin with a complete design environment that's cloud-enabled through something called a platform as a service. So this is a way to jumpstart the creation of solutions if you're beginning with nothing to start with. And many of the same providers offer these, but there's also a few other companies who don't have infrastructure as a service who provide platform as a service. An example would be the company Salesforce. They have a platform that's based on some of what they learned as a software as a service company that they use at the platform level. And then putting all of that together, the culmination of the cloud is typically represented in something called software as a service or SaaS. And a SaaS solution is typically one where the user is really only responsible for managing who uses the service. And the company that delivers this is responsible for all aspects of the solution itself, the software, the underlying compute, and the service and support that goes along with it. And we're quite familiar with these in our everyday business life in the companies like Salesforce, Workday, ServiceNow, Slack, even all these Microsoft applications that people use that are cloud-based are really sold as a software as a solution.
That makes sense. Now, Craig, you've been in this cloud computing arena for a long time. What have you seen are the most common cloud concerns?
The concerns differ according to what type of customer or user you are. When I break this down for a company that's doing silicon design and thinking about the compute requirements that they have, they typically ask questions like these. The primary concern is almost always beginning with security. Is it secure? What happens to my data? How much is this going to cost? It's not just about the benefit of having this huge compute pool, but it always boils down to what the CFO is willing to allocate. Many times what happens is the companies have these big investments in their own data centers and their own server farms, often like private clouds themselves. And they need to answer the strategic question is, what will happen to this compute if I try to use the cloud? A practical consideration emerges when they think about how to deploy it. Many companies have very experienced IT groups that are building and managing their on-prem server farms, but that doesn't necessarily translate to the same skill set that's needed to handle the cloud. So a company has to thoughtfully think about whether the IT group can handle it. With anything, when you move to a new type of solution, if you're going to give up your server farm infrastructure, you want to be very careful. And many customers ask, what will happen? Will they get locked into one cloud vendor and then be forever beholden to what that vendor wants to provide or charge them? Another big consideration is to understand what software might be available. If something that you use today on-prem doesn't work in the cloud, that can be a big problem. And finally, from a Cadence perspective, we always talk to customers and they're almost always interested in understanding, is someone already doing this? No one typically wants to be the first. So there's a lot of concerns, and it's not a simple task about just making a phone call and switching to the cloud. It really has to be part of a strategy.
It certainly does seem like that. Okay, Craig, let's step back a sec and talk about on-site IC design versus cloud-based design. What do you see are the biggest hurdles in on-premise design?
When we talk to customers who have these large investments, there's benefits to the way that they're deployed, and there's also some issues with that approach. A graph like this, which tries to very simplistically depict what the requirement is from a compute standpoint for doing electronic design, where the red line, this wave of up and down, represents how much compute is required at any given time during the course of a project, versus the green dotted line, which is a representation of the available on-prem capacity. And what you can see happens is that the red line doesn't match what the green line has available to it. And when that occurs, some interesting dynamics emerge. Whenever the red line is above the green, what we have is an engineer waiting for compute. The reverse of that is when the red line is below the green, you have scenario 2, where the server is actually idle, meaning that there's a capital expenditure that's not being utilized. And the other interesting thing that happens is that when a company relies solely on on-prem compute and their required demand increases, they need to respond and add more capacity. And that takes time. Time in the form of identifying what types of servers to purchase, working through the purchase process itself, taking delivery of those servers, installing those servers, configuring the operating system, and finally having those servers ready to use. So that can take months, and that doesn't necessarily match the requirement of an electronic design project. So these are all hurdles and challenges associated with the historical model of on-prem compute.
Sure, that makes sense. So, Craig, how does a cloud-based compute environment compare? And not all clouds are the same, right?
You're right, Amelia. There's different ways to utilize the cloud. This simple diagram explains that any of these three models are actually possible with the cloud. Where we are today in the community is largely big companies have exclusively on-premises compute. It's really what we were showing on the prior picture, where the red line doesn't really match the compute that's available. Now, that's positive in some ways. The compute's already in place. It's customized to what a customer needs, but it comes with some issues. The capacity itself is capital expense. And that means you're depreciating it over 4 or 5 years. You have an IT team that's supporting it, and it's relatively inflexible, as we just described. It's got these issues with idle engineers, idle compute, time to deployment that can take a lot of time. That model is imperfect. So what can the cloud do to help? Well, the easiest thing is actually to jump all the way to the right-hand side and go all cloud. Why is that easier? Well, you can switch your OpEx to CapEx, and that is generally preferable to the CFO. It's also very resource efficient. If you look at the depiction, the blue exactly matches the red, meaning that you're never really paying for compute that you didn't use. The challenge, though, is that that transition is tricky, especially if you're one of these companies that has a huge server farm investment. And the other thing that we hear a lot is that moving all to the cloud introduces this concern over controlling expense. The companies know that the cloud is an infinite pool of compute, and their worst nightmare is that an engineer over the weekend somehow consumes 3 weeks worth of compute budget by launching something, incurring a huge cloud expense. So those are some of the mitigating factors. A little bit like, the Goldilocks, too hot or too cold or just right. Hybrid cloud is kind of in the middle, and it's very attractive for its agility and scalability. It's an incremental change. The companies don't have to get rid of their on-prem environment to use the cloud, but it comes with some significant challenges. You still have all of your issues with your on-prem support that you need to deal with. When you begin using the cloud, you've just introduced new skills and requirements and knowledge that your IT group will need to have. And the tricky thing actually turns out to be data management. When you're either all on-prem or all in the cloud, you don't have to really worry about extra copies of your design floating around. Once you're trying to do some work in 2 locations, you have to make sure that you're working on the right version of the data every time that you use the cloud or your on-prem environment. So it's not straightforward. There's no one right solution, but you can see that there's a lot of factors that would go into making that decision.
For sure. I can definitely see how different factors would come into play here. Craig, since your name tag says Cadence, I'm guessing Cadence has some solutions in this space?
We're always concerned about our customers' best interests, but that doesn't mean that we're not also interested in promoting what we can provide and help our customers achieve. And in fact, I'll talk a little bit about our portfolio in the context of the challenges and opportunities that we just walked through. And in fact, you'll see that in our portfolio, we've got solutions that address the various types of cloud environments that a customer might be interested in deploying. So if you look at our portfolio from the top level, you'll see that we've got a lot of information on the slide, a lot of graphics. I think it will probably make sense for us to talk through each of these clouds in a little bit more detail. But before we do that, I just want to paint the broad picture that depending on what the customer wants to achieve with the cloud, and we've been through a little bit of the range of possibilities in some of our prior conversation here, Cadence can take a different role, and the customer may actually have different expectations. So The top level way that we have heard customers think about the cloud when we go talk to them about what are our capabilities as a company, they typically either want to manage their own environment or they want Cadence to help them manage their environment. And that's a very fundamental decision when it comes to the cloud enablement. And rather than try to force every customer to only use a Cadence managed cloud environment, we felt like it was going to be much more palatable to give customers the option to do it however they would like to do. And whichever approach they take, we've put together models and programs to make that a little bit easier. At this level, just notice that when a customer is going to manage their own environment, they can do that either 100% in the cloud or partially in the cloud. That's really up to the customer. On the Cadence managed side, you'll see that we have options for full cloud environments as well as these hybrid environments. And then a new type of solution, which we really haven't talked about yet, is what do you do about hardware emulation? And we'll talk a little bit more about how that can play a role, why the cloud angle is important here. And our customers can have an all cloud environment or they can have a hybrid cloud environment there as well. I think at a high level, that's a description of where we can go, and it might make sense to dig into each of these in just a little bit more detail.
Okay, let's do just that. So let's start with that cloud passport. Craig, what's that all about?
We thought about this a lot, and what we realized is that a customer who wants to manage their own environment probably has some top-level careabouts. The first would be that the software is going to work. So that has to be assured from a testing perspective. So the first value add that Cadence can bring to that deployment model is to make sure that our software will work well in the approved environments. And what we have currently certified are AWS, Azure, and a Google Cloud Platform. We've taken our tools, we've deployed them, we've run them, we've done security analysis on the services, and we feel any customer who wants to use those three is certainly going to have a good experience. It doesn't mean that we wouldn't consider supporting others. It's just that these three actually constitute the majority of the requests that we get. So that's one thing that we do. The other thing that customers care about is, well, how will the tool perform in the cloud compared to maybe how it would perform in my own server farm? Well, to make the tools better, we started re-architecting them starting many years ago, actually. As you can imagine, changing the architecture of a EDA tool isn't something you can do overnight. There's so many elements of a given piece of software that have to be carefully constructed and coordinated to make that happen. So starting 4 or 5 years ago, we began that process, and now you'll see that the tools that Cadence makes available are highly parallelized. Now, why is that good? Well, highly parallelized means can utilize lots and lots of compute. Where is there lots and lots of compute? It's in the cloud. So the fit architecturally is really good with our products. The other thing that we can do for a customer who wants to deploy in their own cloud environment is make sure that they've got the license server that makes sense for them. So a license server is a key piece of enablement that's required in order for any EDA tool to run. And when a customer deploys in an on-prem environment, that license server sits right there in their data center. But when they want to utilize the cloud, there's a choice that they would have to make. Do I add a second license server that can run in the cloud, or do I try to run from the same license server that sits on-prem? Our advice is to add a second license server, put that license server in the cloud right next to the software where the software is running, so that the tools never have a dependency on a network connection that would go outside the cloud, back across the internet, through a company's firewall to a server that may or may not actually be available. So that's what we mean when we say a cloud-based license server for higher reliability. So those are some of the key things that Cadence brings to the table. The other thing that we did, and we announced this at DAC last year in 2019, we put together a collection of partners that we call Passport Partners. And these are companies who specialize in taking high performance computing to the cloud. We worked specifically with a subset of the companies that do this. We wanted to work with companies who had experience with EDA and who specifically had traction with Cadence customers. So you'll see in that bigger picture that we looked at previously, a small circle that contains a lot of different logos, but these companies can help any of our customers have a successful experience at moving to the cloud. It's not a Cadence managed solution, it's going to still be their solution, but they can get some advice, assistance, and in many cases, even enablement software that makes that experience a little bit easier. So that's the Cloud Passport. It's available for use with any of our Cadence products, and it's a good option for companies who really want to control every aspect of their cloud experience.
So, Craig, CloudBurst is the Cadence managed platform, right?
Correct. It's one of two platforms that we have for software. CloudBurst is a Cadence managed environment for hybrid cloud use. Remember that hybrid cloud is the most complicated of the cloud deployment models. When you want to have a hybrid environment, you immediately need to both securely enable the cloud as well as manage the workflow and the data that you will utilize. Thinking about this problem, we realized that one of the things that Cadence could do, perhaps even uniquely, is give the customer our tool already set up and ready to run in the cloud. And that's what CloudBurst is. It's the simplest and fastest way for a customer to have a hybrid cloud environment with a Cadence product ready to go. We thought through this from the ground up, and we realized that one of the bigger challenges in setting up a cloud environment is the IT complexity. So the cloud has a ton of services that are available for anyone to use. You can think of it as a very large menu, and it's actually overwhelming if you're not familiar with what those services do and what their limitations might be. So Cadence has configured an environment that is secure, that gives access to any type of compute that's in the cloud, and that service is all done in such a way that the customer doesn't need to do any IT setup. It runs in a browser. And that's a significant achievement because, as you know, Amelia, EDA software is among the most complex and has the highest performance requirements of almost any type of software that's out there. And it's no small task to make that work, whether it's an interactive kind of workload or a batch workload. The other thing that I mentioned about the challenge of a hybrid cloud environment is the need to manage the data. What you can typically experience when you're doing a low nanometer design and you're in the back end of that process after having laid out the chip, placed all of the nets and ready to analyze it, the file size can be very, very large. And if that file has to move, which it does if you're using a hybrid sort of solution, you need to move it very, very quickly. So we have developed some high throughput file transfer capability where a customer is able to move files that are on the order of 500 gigabytes or even a terabyte or a terabyte and a half in a reasonable amount of time. And one customer experienced this firsthand, where without this technology, it was taking close to 20 hours to move a file. And that was significantly interrupting the workflow they wanted to have. Well, when we applied this high throughput file transfer capability, we got that down to about 6 hours. And that dramatically changes the usability of the platform. The good thing about CloudBurst, this is an enablement platform. You still have access to all of the tools that we architected to be very cloud friendly and cloud ready. And fundamental to using the cloud is actually having the environment secure, not just secure for your own IP, but even secure for third-party IP. And in particular, we find that the foundries have quite high sensitivities to where their PDKs, their process development kits, reside. And this platform, along with the other Cadence managed solution, meets those partner security requirements. A lot of work goes into this, and generally, as you know, the simpler something is, the more complex it is to implement. I think this is a good example of one of those situations.
I think you're very right, Craig. Okay, so how exactly is cloud hosted different from CloudBurst?
What we really relate it down to is the use model that the customer is selecting. That CloudBurst that we just talked about is really about a hybrid situation, one where the customer intends to maintain an on-prem environment as well as to selectively use the cloud. A cloud-hosted design solution is really optimized for the customer who wants to go all in on the cloud. They've reached the conclusion that their value add as a company is probably more in the expertise of the designers and not so much in having IT or CAD resources spending a lot of time configuring those environments. So if a customer wants to go all cloud, we typically talk with them about this cloud-hosted design solution. It's a turnkey experience in that they get the cloud infrastructure, they get our software installed, they get the CAD and IT support, and help with every aspect of moving that design project from its initial concept all the way through tape out. That's really the difference. Is the intended purpose is generally for full projects. They don't want to have two environments, they want to have one. And this can happen at the project level, or it could be the company itself may just choose not to have any on-prem server farms of their own. We find that a lot of our customers for this really find it liberating to know that they no longer need to worry about what's going to happen when the project reaches a point where the computer that they have in the back is no longer going to handle the workload, or what happens if that engineer who has as a side task configuring the IT equipment decides to leave to go to a different startup or something. All of a sudden, those skill set gaps go well beyond just what maybe one designer would require, and it can be very disruptive. And cloud hosted is a way to manage that risk in a thoughtful and cost-effective way. And like our other CloudBurst solution, this also meets the Foundry partner security requirements. So they're completely comfortable with their IP and PDKs being used in the cloud. It's a much simpler process for a customer to get permission to do that if they're using one of these approved environments.
Cool. I can definitely see the benefits of a cloud-hosted design solution. Now, Palladium Cloud was the last one you mentioned, right? What does that solution buy me as an engineer?
The thing that sometimes is lost when someone looks at a company like Cadence from the outside is that while the majority of what we provide is software oriented, we do have a percentage of our business which is hardware. Specifically, we've got these emulation systems that are called Palladium Z1 emulators, which are purpose-built supercomputers. I mean, this is optimized for the very task associated with taking the description of a design, the RTL, if you will, of the model, and running that in a way that is 10 times faster than is possible on even the best servers in the world. So the first opportunity for a customer that's trying to verify their chip and make sure that they move to the layout phase without it having errors and issues is to thoroughly simulate it. They do that as much as they can on standard compute, but ultimately a Palladium system can allow them to do that much, much faster and at a much larger scale. And it's even capable of modeling their entire design and letting the customer see how that design will interact with the outside world. Palladium is a very useful technology. The challenge can be that to purchase, install, and maintain a purpose-built computing system is a commitment that a customer needs to make. We have a very healthy number of customers who do that because they have designs that will constantly utilize this equipment, and in fact is generally almost 100% utilized, and they build it into their own data center plans. And so we sell a Palladium, and then we have now made available a Palladium Cloud. Just like a model where a customer doesn't own the server infrastructure, in this model, the customer doesn't own the emulator. Cadence has put these emulator systems into a professionally managed data center that has all of the security and power redundancy and operational consistency that you would want. But we've done it in a way that the customer doesn't just have to buy a system. They can buy capacity. Design capacity in this context is generally thought of as how many millions or billions of gates is it that you want to emulate. So we've changed the thing that the customer purchases from buying a system to buying capacity and letting that capacity be utilized when it's actually needed. You can think of this as maybe when you're buying a car, you want to utilize that car as much as you can to get the full value out of it. If you have a situation where you're going to use it for 3 months or 6 months, buying that car may not be the right financial decision. And in fact, if you knew that you could buy 3 months or 6 months worth of car capacity and not be paying for it when you didn't need it, that might be a compelling alternative to owning. And that's what we find with Palladium Cloud. So we sell this in compute capacity units that are essentially months of capacity of a given gate count. So in conjunction with using our software in the cloud, we knew that customers would find this interesting. And this has been a really nice way for new companies to try the cloud for Palladium and big companies to give themselves a little more capacity than they have in the systems that they purchased.
That makes perfect sense, Craig. So keeping in mind these different Cadence cloud platforms, how do they map to the engineered design needs we talked about earlier?
What we see happening is that once a customer understands what the cloud services look like, going all the way back to what we talked about at the top, infrastructure as a service, platform as a service, software as a service, well, you can take the Cadence offerings and map them to these different models. A customer who's really interested in infrastructure as a service will typically want to do customer managed using the Passport model. Remember, in this model, Cadence is supplying software. The customer is then going to the cloud and configuring and developing that cloud on their own. There isn't anything that really matches the platform as a service because if you think about it, the customer's interest is not in creating additional EDA solutions. The customer's interest is in creating a silicon design. And the simplest way to do that is probably using Cadence as a software as a service, meaning that the customer's responsibility is really to think about the users and leave the cloud management to Cadence. So all of the Cadence managed offerings that we just talked about, whether it's cloud hosted or CloudBurst, and even Palladium Cloud, are more analogous to software as a service than anything else. That's a convenient way to think about how the Cadence offerings map to traditional cloud services from the portfolio perspective.
Cool. Okay. So, Craig, what do you think are the biggest hurdles for cloud computing going forward?
There are definitely a lot of companies who are moving aggressively to the cloud, but it would be inaccurate to say that it's across the board. What really is happening is that some of the earlier adopters are experimenting with the cloud and finding what works for them. Others are a little more hesitant or have more complicated internal environments, and they're really waiting. So I think the top thing is probably the unique complexity associated with EDA environments. No two companies actually do this the same way. And in many cases, what they have today is a reflection of years and years of incremental tweaking. As simple as it may sound, is actually very difficult sometimes to know what dependencies a given piece of software has. There's so many things that are done through automation and scripting. So one of the things that happens is that these customers have incrementally improved their CAD environments little by little in such a way that they may not even know exactly what all those dependencies are. Finding a file, knowing what an application requires can be a difficult task. So that's something that is a challenge in terms of trying to decide when to go to the cloud. Another thing is this hybrid model that we talked about. Hybrid is by far the most intriguing of the cloud models. It seems to give you the best of both worlds, but it also brings with it that data management task. We've done a lot of things to make the data management easier, but it still is data management, and that needs to probably be further optimized in order for companies to get more comfortable with the cloud. Another thing that we see is that the urgency that a customer typically has to meet a tape-out schedule or to complete a project on a deadline is so extreme that there's almost never a good time to transition to the cloud, a different environment. It's an incremental risk that they may not feel comfortable taking until a project is concluded. And it may be that as the project concludes, there's something else that's pressing. So there's almost never a great time to redo something. And companies who are moving earlier are just taking a strategic choice to do that now. Others maybe are waiting and being a little bit more reactive. Another interesting item is the total cost of ownership, or TCO. One of the fundamental things in IT is trying to understand what the complete cost of your environment might be. And that goes well beyond what the cost of the hardware is or the storage. That's relatively easy to determine because you get an invoice from the customer when you buy that. What is a little more subtle is, what is the real estate cost of having a data center? What is the power requirement that you're paying? And how does that power bill change based on how much compute you use? So those kinds of things, including the labor that's associated with the IT people supporting that, have to be in the calculation. And it's not as easy to do as one might think. And as a result, that tends to be something that a lot of analysis goes into. And finally, something that is top of mind for most of the customers is expense control. There's tremendous flexibility that's inherent in a cloud, but it also means that if you don't properly set constraints, policies, and limits, you may find yourself as a CFO writing a great big check for the cloud that wasn't part of the original forecast. So the fear of losing that kind of control can be a hurdle as well. So while we're on a great trajectory already with a lot of companies using the cloud, there's still even many more that I think will eventually get there as we as an industry and as a company help them address these major challenges that I've described.
That makes sense. So, Craig, I think it's time to wrap things up. What are your main takeaways from today's Chalk Talk?
Thank you, first of all, for allowing me to come in and chat with you about this. I think it's a really interesting topic, one that we find more and more customers want to engage with us about. So for me, I think the way that I look at the cloud, and from a Cadence perspective, we think this is the future of electronic design, that this is a compute model transition. You know, we started this conversation talking about the history of high-performance computing going all the way back to mainframes and having evolved now all the way to the cloud. And EDA and IC design and electronic design in general are now making that transition to this new compute model. And what's most important for that to happen are the things that Cadence is trying to bring to the world with our portfolio. We think that a customer will want to deploy very quickly. They want that adoption of the cloud to be relatively painless, and they want to do that in a way that's proven. You know, no one wants to be the experiment. You know, everyone wants to be learning from history. So I think in a nutshell, all of those things are important, and we're just excited with the opportunity that exists for our customers to actually get more done in less time by taking advantage of the value of the cloud.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Craig. It was a pleasure speaking with you.
It's been great, Amelia. Thank you so much.
Before we go, you didn't forget to click that link, did you? There you can find even more information about the Cadence Cloud portfolio. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it. It's right across the top. or head on over to YouTube, youtube.com/EEJournal.